Hello friends, welcome to Learner's Planet. Friend, in this session we'll be discussing area perimeter of plane figures. Maybe if we talk about triangle, quadrilateral, uh, this hexagon and all that. Though we have already discussed the things in our basic surface area and volume sessions, still in this particular sequence when we are discussing geometry sessions differently, we'll just go for a quick recap of all the concepts and formula once again. Right? So let's begin the session. Now, the first term, that is perimeter of a triangle. Suppose A, B and C units be the length of the sides, then perimeter will be A plus B plus C. We have triangle ABC over here. The length of the sides are A, B and C. Then the perimeter will be sum of the sides, that is A plus B plus C. Right? Then we have one more term S, that is actually semi perimeter. Semi perimeter is actually half of the perimeter. Right? So perimeter is A plus B plus C, half of that will be A plus B plus C by 2, and that is actually S, and we call it as semi perimeter. So precisely 2S is equal to A plus B plus C, or S is equal to A plus B plus C by 2. Right? Then we have formula for area of triangles. Right? Here we are talking about any random triangle, not specifically this equilateral triangle as the figure. Okay, just what I do is I take another triangle over here. Okay, and this is a scalene triangle having the sides A, B and C. Right? Then semi perimeter will be A plus B plus C by 2, and area of this triangles, we call it as Heron's formula for area of triangle, is given by square root of S into S minus A into S minus B into S minus C. A, B, C are sides of the triangle, that is a scalene triangle. S is the semi perimeter, that is A plus B plus C by 2, and area of the triangle is given by root of S into S minus B, A, S minus B, S minus C. Now suppose it is an equilateral triangle. Now if it is an equilateral triangle, what would happen? A, B and C, all of them will be same. Okay, so S will be A plus A plus A by 2, that is 3A by 2. Now if I put the value of all of them into the formula S, S minus A, S minus B and S minus C, then see what happens. So just put S is equal to 3A by 2, so it is 3A by 2, S minus A, that is 3A by 2 minus A, that is A by 2. It will also be S minus B is equal to S minus A, so it will also be A by 2, and similarly this will also be A by 2, and we have square root of this. Now just see, out of 4A, outside the square root there will be 2A, that is A square. Then 2 raised to 4 out of the square root, it will be 4, and we have a root 3 inside the in fact we have root 3, that is 3 inside the root. So it is root 3 by 4 A square. Very important formula for area of an equilateral triangle. Right? So area of an equilateral triangle is root 3 by 4 side square. Here the side is A, so it is A square, otherwise it is root 3 by 4 side square. Okay? So you must be knowing the Heron's formula, so you can easily find out the area of any triangle if the three sides are given. Okay? Now here some very important relationships we are going to discuss. Sine formula and cosine formula. I have a triangle A, B, C. Right? Now the side opposite to angle A is length A, side opposite to angle B is B, and side opposite to angle C is C. Right? Okay. Now we have sine formula. Sine formula is sine A by A is equal to sine B by B is equal to sine C by C, where A, B, C are these sides as I have explained earlier. Okay. A is the length of the side opposite to angle A, B is the length of side opposite to angle B, and C is the length of the side opposite to angle C. So sine A by A is equal to sine B by B is equal to sine C by C, a very important relationship. right? And area of the triangle can be calculated as half AB sine C, half BC sine A, half AC sine B, right? So if you have two lengths, suppose you have length A and C and you know this angle, then you can calculate the area of this triangle, right? So to be able to calculate the area of a triangle, what you need to have is the length of two sides and their measure of their included angle, right? So if you have angle B, length A and length C, you can calculate the area of the triangle. Okay, obviously area of the triangle will be same in all the three cases. So we equated them, and when we equate them and divide by ABC, that is small a, small b, small c, that is length of the sides, we get this relation. Okay, so sine formula, it's very important. Area of the triangle can be calculated from this also. One more relation we know, that is half base into altitude. Suppose this is altitude L, then half BC into L, that is this way also we can calculate the area of the triangle. Okay, so Heron's formula I have told you, sine formula to find out the angles I have told, to find out the area of the triangle I have told you, and this is the general formula, that is half base into altitude, right? Similarly we have very important cosine formula. Now suppose you know the length of two sides and their angle measure, that's included angle, then the third side can be calculated, or maybe any other way, or other ways also you can use it. So cos of A is equal to B square plus C square minus A square by 2 BC. Here A is angle, and when A is angle, the side opposite to it will be deducted. Okay, so this way you can learn the cosine formula. Okay, we'll be using it so many times, cosine formula and sine formula and area of triangle, this formula to find out the area of triangle, right? So just note down the three of all of them are really very important. Okay, similarly we discuss perimeter and area of a rectangle. Suppose I have this rectangle where L is length and B is breadth, then perimeter will be 2 times L plus B and area will be L into B. So that's pretty simple. You might have learned this formula in your junior classes, maybe grade 7, grade 8. So these are very simple. Let's go for a quick recap of properties of rectangle. In case of a rectangle, all the 4 angles are of 90 degree, right? Then this side and this side, these are parallel to each other. This and this, they are parallel to each other. All the angles are 90 degree. This side and this side, not only they are parallel, but also they are they have the same length, or they have equal length. Similarly this side is equal to this side. Okay, apart from that, the length of the diagonals, that is the length from this point to this point, that is diagonal, and this diagonal, the length of both the diagonals will be same, and diagonals bisect each other, right? Diagonals bisect each other, but not necessarily at 90 degree, right? Be very clear about it. The diagonals of rectangle bisect each other, but not at 90 degree. Okay, so these are the important properties of a rectangle that you must be knowing. Similarly, we have a square. Perimeter and area of square. We know that all the 4 sides of square are equal, right? All the sides are equal. All the 4 angles will be 90 degree, and diagonals will be equal. This length will be equal to this length. Then the important thing over here is the diagonals are perpendicular to each other. I just wait for a moment. So here I have shown one square. The diagonals may be A, P, B, D. Okay, AP will be equal to BD. The diagonals will be having same length. The angle between the two diagonals will be 90 degree, and angle between a side and diagonal is 45 degree, right? So the diagonals are perpendicular to each other. Diagonals were not perpendicular to each other in case of rectangle. Okay, in case of rectangle, opposite sides are only equal. In case of square, all the 4 sides are equal, right? Let's move further. Next we have parallelogram. It is also one sort of quadrilateral having four sides. The opposite sides are equal. That means this side and this side is equal, and this side and this side is equal, right? None of the angle is 90 degree. So that was the difference between a rectangle and a parallelogram. In case of rectangle also the length of opposite side is equal, but in case of rectangle all the angles are 90 degree, but in case of parallelogram the angles are not of 90 degree, right? The next difference is in case of a rectangle the length of the diagonals is same, but in case of parallelogram length of the diagonal is different. You can very well see this diagonal and this diagonal, both of them are having different lengths, right? But this side is equal to this side and this side is equal to this side, okay? And important thing over here, the opposite angle, that is this angle will be equal to this angle and this angle will be equal to this angle, right? Opposite angles of a parallelogram are equal, right? And sum of base angles will be 180 degree. That means this angle plus this angle will be 180 degree, okay? What will be the formula for area of parallelogram? That is half base, only base into altitude, not half, it is base into altitude, okay? That is the area of a parallelogram. In case of triangle the area is half base into altitude. In case of parallelogram it is only base into altitude. So we can say that the diagonal of a parallelogram divides the parallelogram into two equal triangles, okay? So here if it is A, B, C, D, then area of triangle ABC will be equal to area of triangle BDC. ABC and ACD. Area of triangle ABC will be equal to area of triangle ADC. Okay, so AC divides the triangle, that is AC is diagonal, it divides the parallelogram into two equal triangles, okay? This diagonal as well as this diagonal, okay? Diagonal AC and diagonal BD, both of them. Next we have rhombus. If all four sides of a parallelogram are equal, then it is a rhombus. Now what is the difference between a rhombus and a square? In case of square all the four angles are equal. Along with all the four sides, all the four angles are also equal, but in case of rhombus all the four sides are equal but all the four angles are not equal, right? You can see this angle is equal to this angle is equal to this angle, but this angle is not equal to this angle, right? So that is the difference between a square and a rhombus, okay? Perimeter as usual 4 into side, because all the four sides are equal. Then area of the rhombus is half product of the diagonals, okay? So that is the area of rhombus. Now what are the properties? Opposite sides are parallel. This side is parallel to this side is parallel to this side, all the sides are equal. Opposite angles are also opposite angles are equal, as I've already told you, and diagonals bisect each other, right? This diagonal and this diagonal, they bisect each other, and very well you can see the angle or we can say the diagonal bisect each other at 90 degree, okay? So this angle is 90 degree. So in case of square also the diagonals bisect each other at 90 degree, but the angles in square, all the four angles, right, they are 90 degree, and in this case they are not 90 degree. So that's the difference between a rhombus and a square. Now next we have trapezium. A quadrilateral which has one pair of opposite parallel sides is called a trapezium. So here we can see this side B and this side A, they are parallel to each other, but this side is not parallel to this side, okay? The distance between these two parallel sides is h, that is altitude of this trapezium, and the formula for area is half of this sum of parallel sides into distance between them. So half of A plus B into h. So that is a formula for area of trapezium. A trapezium is known to be an isosceles trapezium if these two sides are equal, right? See, this side is not equal to this side. If these two are equal and these two are equal, then it will be converted to either a parallelogram or a rectangle or a square. So if these two sides are equal, then it will be an isosceles trapezium, right? These two cannot be equal, as I've already told you. In that case, if these two are also equal and these two are also equal, then it will be a parallelogram or maybe a rectangle, something like that, right? So isosceles trapezium, that means both the non-parallel sides are equal, right? Next is right angle trapezium. So in case of right angle trapezium, we have one angle as right angle. Right, so this is right angle and this is the right angle trapezium. This line is parallel to this line. Okay, in case of area formula, it will remain same in all these cases, whether it is a normal trapezium, isosceles trapezium or right angle trapezium. In case of right angle trapezium, this length will be equal to the distance between the two parallel lines. Okay, now let's see, how do we find out the area of a quadrilateral? Here I have drawn a quadrilateral, maybe suppose A, B, C, D, and this is the diagonal BD, right? And this is altitude, I suppose this is P, and this is also altitude, I suppose K, right? Now area of this quadrilateral ABCD will be area of triangle ADB plus area of triangle BDC, right? Area of quadrilateral ABCD equal to area of triangle ABD plus area of triangle BDC. Now what is the area of triangle ABD? ABD, that is half base into altitude. So it is half DP into AB. Okay. Plus area of triangle BDC half BQ into DC. Right? So it depends upon the lengths of bases as well as altitude. So this is how we can calculate the area of quadrilateral. Okay. Now some important theorems related to quadrilaterals. Here first we discuss the theorems for a parallelogram. A parallelogram on the same base and between the same parallels is equal in area. Suppose I have two parallel lines. Now this is the parallelogram A, B, C, D, and this is P and Q. Now parallelogram A, B, C, D and parallelogram A, P, Q, B. Both of them are between the same parallels, you can say. Suppose this is L, this is M. L and M are parallel to each other. So both of them are between same parallels and both of them are having the same base, that is AB, right? So area of parallelogram ABCD and APQB will be same. Right? What is the area of parallelogram? That is base into altitude, right? So base is same in both the cases, that is AB, and altitude will also be same because both of them are between the same parallels, right? So if both the things are same, then area will be definitely same. Okay, so parallelogram on the same base and between the same parallels is equal in area. Okay. Now the area of parallelogram is equal to that of rectangle on the same base and of the same altitude between the same parallel lines. Precisely, parallelogram is nothing but a rectangle. I just draw one before you. It's a rectangle, the sides tilted. Okay, So area will not be changed. So this is, I am drawing a rectangle. Okay, now what if the sides are tilted? Like this. I'm just tilting the side and shifting this side bit right hand side. So area of rectangle and area of this parallelogram will be same because I have not moved, I have not changed the altitude, I have not changed the length of the base. Okay, what is the area of a rectangle? That is length into breadth, or we can say height into length, right? And the same is parallelogram. Okay, so I hope that's clear to you. The area of a triangle is half of the area of parallelogram on the same base and between the same parallels, right? Here we have two parallel lines, FC and AB, and the area, the triangle if we make, that is AEB, area of this triangle will be half than that of this parallelogram, right? Now what is the area of a triangle? That is half base into altitude. And what is the area of this parallelogram? That is base into altitude. Just draw. Area of parallelogram will be base, that is AB into altitude, and area of triangle, that is AEB, is equal to half base, and altitude will be same because both of them are between the same parallels, right? So this distance will be same in both the cases, right? So this is AB into L, this is half of AB into L. That means the area of this triangle is half than that of the parallelogram. Okay, most of the theorems related to triangles and quadrilaterals we have discussed. Brief idea of hexagon I just gave you. See, a regular hexagon is a combination of 6 equilateral triangles. Okay, so if you draw the diagonals of the hexagon like this, you'll be able to get 6 equilateral triangles. Okay, since we know that each angle of a regular hexagon is of 120 degree, we have already discussed this. So this is 120 degree, this is 60, 60. So a regular hexagon is a combination of 6 equilateral triangle. So the area of a regular hexagon is √3/4 side square into 6. Right, because what is the area of an equilateral triangle? √3/4 side square, and since there are 6 equilateral triangle, the area of hexagon will be √3/4 side square into 6, right? There is no specific formula for area of pentagon, right? So it depends upon the situation. Whatever the data is given to us, according to that, if our concepts are clear, then we can find out the area accordingly, right? Now we discuss some important points related to triangles, where we'll be using the trigonometric ratios also. Okay, so let's begin, and these are very important also, just note them down. Now a triangle has 6 components, 3 sides and 3 angles. The 3 angles of triangle ABC are denoted by letter A, B and C, and the sides opposite to these angles by letters A, B and C, small ABC respectively. We have already discussed the sine formula and cosine formula, right? The sum of the 3 angles must be 180 degree, or we can say it's pi. Then sum of any 2 sides will be definitely greater than the third side. So that's really very important. Sometimes you may be asked in your exam whether you will be able to draw a triangle of these given data or not. Suppose you have A, B and C. Now this is 3, this is 4, suppose this is 8. Now if you are asked how many triangles can you draw when the sides of the triangles are ABC, that is 3, 4 and 8, right? So you cannot draw even a single triangle with these data. Why? Because A plus B is less than C, right? So it is necessary that sum of 2 sides should be definitely greater than third side, not even equal, it should be greater, right? If A plus B is equal to C, then the points will be collinear. they will be on the same line, right? And A plus B, if it is less than C, then also the points will be collinear. Okay, so the only condition when the 3 points will make a triangle is A plus B should be greater than C, right? Length of two sides, sum of length of two sides should be greater than the third side. Similarly, A minus B should be less than C, B minus C should be less than A, C minus A should be less than B. Here we are taking the positive difference. Maybe A is greater, maybe B is greater, but we have put up A minus B under modulus sign, so we just get the positive value of A minus B, right? So difference between lengths of A and B should be less than C, B and C should be less than A, and C and A should be less than B. Okay? This we have already discussed, the law of sine or sine rule. The sides of a triangle are proportional to the sines of angle opposite to them. In this over here we'll be taking the concepts related to circle and triangles, right? So A upon sine A is equal to B upon sine B is equal to C upon sine C is equal to K, and over here you can see a circle, that is a circumcircle precisely. Circumcircle, that is the circle circumscribing the triangle when all the 3 points or the 3 vertices of the triangle are on the circumference of circle, right? So, and precisely circumcenter is the concurrence point of perpendicular bisectors that we have already discussed, right? So here I assume the circumradius is capital R, right? So A upon sine A is equal to B upon sine B is equal to C upon sine C is equal to 2R, where R is the circumradius of the circle, or the radius of the circle. Okay, so this is the important relationship that you must be knowing. So sometimes depends upon the given data. I just take one example over here. A upon sine A is suppose 2R. No, it's not suppose, it is actually 2R. So A upon 2R is equal to sine A, right? So if you know the radius of the circumcircle and you know the side, that is side A, then you can find out the sine of A. That means angle A can be found out. So this is just one of the application of this given relationship. Okay, here R is circumradius. Some more important relationships are here. Just note them down. Sometimes they are used to save time, you can say. In any triangle ABC, A is equal to B cos C plus C cos B. Similarly, B is equal to C cos A plus A cos C. So just note them down. Where 3 sides and the circumradius are given, then the area of triangle is ABC by 4R. And when in radius is the relationship between in radius and area of the triangle is in radius is equal to area of the triangle by semi perimeter. Okay, so precisely if it is an equilateral triangle, then area of triangle will be equal to ABC, all of them will be equal. So area is equal to A cube by 4R. Okay, or you can say circumradius will be equal to A cube upon 4 area of triangle, right? Similarly, R is equal to thus in radius area of the triangle by semi perimeter. So if all the 3 sides are equal, it will be 3A by 2, right? So sometimes you need to equate the formula. Say here area is A cube by 4R and here area is equal to, in this case, just a moment. Here we are talking about the same triangle. Here area of this triangle is A cube by 4R and here area of triangle is equal to 3AR by 2. So you can find the relationship between circumradius and in radius. Okay. Now we find the relationship between the altitude of an equilateral triangle and radius of, or we can say in radius, right, or radius of in circle, right? Now this is an equilateral triangle and this is in center, so this angle must be 30 degree. This entire angle must be 60 degree, so this angle must be 30 degree, right? This is in radius, that is R. Okay. So for this triangle, suppose this is OAB, triangle OAB. Here it is C, here it is D. So it is triangle OAB. This angle must be 90 degree, the angle between the radius and the tangent. So this is R. So relationship between this and this is given by tan theta, right? So tan 30 degree is equal to radius by AB. And if now we take triangle DAB, this entire angle is 60 degree, so I take tan 60 degree is equal to height of the triangle by base AB. Okay, so here we can equate AB. Tan 30 degree is equal to 1 upon root 3 and tan 60 degree is equal to root 3. So here AB is equal to h upon root 3 and over here AB is equal to r root 3. So in both the cases AB will be definitely equal. So h upon root 3 is equal to r upon root 3, or we can say r is equal to h by 3. Right? Here h is what? Height of this triangle. Okay, so in case if it is an equilateral triangle, radius of the equilateral triangle is 1/3 of its height. That's an important concept. Radius of an equilateral triangle is 1/3 of its height. Okay, that we have proved over here. Radius r is equal to h by 3. Okay, similarly here it is in radius. Similarly we find the relationship between circumradius and height of the triangle. Now this is circumcircle. Circumcenter must be somewhere here, and this is, just draw it neatly. The circumradius. Okay, one more line I just draw over here. Now since this is an equilateral triangle, this angle must be 60 degree, right? And you might have learned that from any arc, the angle at the center is double than that of the angle at any other part of the circle, right? So if this angle is 60 degree, it has to be 120 degree. Okay, so the complete angle is 120 degree. That means this portion is 60 degree and this remaining portion is 60 degree, because altitude divides the triangle into equilateral triangle into two equal parts, right? So this is 60 degree, this is 60 degree. So we have this 90 degree, and this portion to be 60 degree, then this will be 30 degree. Okay. Now this is what the radius of the circle, and this is what the height of the triangle. Okay. So I just name P, Q, R, S. This is O. Height of the triangle is PS. That is actually PO plus OS. Now PO is nothing but radius of the circle, and OS. Okay. Now in this triangle OQS, the relationship between hypotenuse and perpendicular is given by sine theta. Okay. So sine theta over here is 30 degree is equal to OS by R. So that is 1/2. So precisely OS is equal to R by 2. So height H is equal to, we just put up the value of S over here. So H is equal to R plus OS is equal to R by 2. So it is 3/2 R, right? or we can say r is equal to 2 by 3 h. Here r is circumradius. Be careful about it. So before this we proved that in radius is equal to 1/3 of height. Now we have proved that circumradius is 2/3 of height. Okay, so both the relationships are very important when you talk about equilateral triangles. Okay, so all the concepts related to circles and triangles must be clear in your mind. We have discussed sine formula, cosine formula, then we discussed the sine formula to find out the area of the triangle. We discussed in circle, in center, circumcircle, circumcenter, and various other relationships, right? So all these sessions are really very important. Just note down all the important points and just go for these sessions at least 2 to 3 times. So all the concepts should be there in your mind, right? While I was deriving these relationships, various things I had discussed, right? This is on this particular concept that suppose this angle is given to you, right? If this angle is given to you, you need to find out this angle. So good number of questions on this concept you are asked, right? So if you know that angles in this arc, right, at the center is double than that of the angle at any other part of the circle, so you can do these sort of problems very easily, right? So all the relationships, all the formula concepts you must be knowing. Okay, from next session I'll be taking problems from triangles. Sometimes we'll be clubbing circles also, because in almost all the competitive exams, if we talk about problems from the combination of circles and triangles are very frequently asked. Okay, so do revise this session, all the 3 sessions of triangles, and do revise the basic sessions of circles also. So once you are clear with all basics, you will enjoy doing problem solving sessions. Okay, bye bye.